I will just introduce you to the participants, and then you can start.
Sounds good. Do you want me to start presenting, or are you gonna say a few words, or?
Yeah, yeah. I will just introduce you to the participants. So welcome, sir, and all who are present here. It's lovely to see you all here. I am Abhijit Dattagupta from Hex-Star Universe, and will be your host for the session. First of all, thank you everyone for taking the time to join us today. So today on 24th April, we have arranged a very special live session for you. Our topic for today is careers in aerospace engineering. And today our speaker is George Salazar, who is LSM-IEE at Human Computer Interface Branch Avionics System at Division of NASA. He has been involved with the design of advanced telemetry, voice recognition, and intelligence systems, of which he has received various patents. He served as the subsystem manager for the Space Shuttle Modular Auxiliary Data System to designed to acquire space shuttle engineering data. Now I request Sir George Salazar to proceed with today's session. Thank you.
All right, I think that was the go ahead to start, and thank you for having me here. I'm going to turn on my camera for a bit here, hopefully, um, and and just say hi, um, and then I'll turn it off to save bandwidth. Sometimes that's a problem when I'm presenting, especially internet and to another country. So again, I think good afternoon over there. Good day for some of you. Good morning here. It's 7:07 a.m. I just had a cup of coffee. I still needed some more coffee to wake me up, but be that as it may, thank you for having me. So when I was asked to give a talk on careers in aerospace, and I kind of struggled with it a little bit. Aerospace engineering in some countries is different than others. So what I'm going to be talking about today is somewhat what I'm familiar with, and that's the NASA engineering, and that's what I'm going to share. And I have to say, for the most part, what I talk about is probably about the same in other countries that are doing space exploration. They all do systems engineering. They all do project management and all that. So uh, let me just say that I'm going to my topics are as follows. Summary about me. Why am I going to talk about me if this is careers in aerospace? Well, the reason I'm going to say a few words about me is because I was not a very good student and didn't, let's say, never thought about going to work for NASA. For the lack of a better term, I stumbled into NASA. And so, some students out there are hoping to work for NASA one day, and I can appreciate that. Sometimes it takes a lot of work, and I have to say that it was a lot of work for me. But again, I did not think I was going to work at NASA, and I'm just going to give a brief background about myself, and maybe some of you students can relate to that. Then I'm going to jump into understanding what NASA does, and I'm as even in my country, students don't really understand what NASA does. What does NASA? When they say the word NASA, they think it's one big building located in a city, and it's not. It's spread out all over the country, and I'll say a few words about that. Then I'm going to start talking about careers at NASA. And primarily I'll be talking engineering, but I'm also going to say some others in passing because NASA does a lot of different things in the field of STEM, science, technology, engineering, and mathematics. And so I wanted to give you a flavor of some of the other areas that NASA does, and it's just for your information. The more you know, the more it makes it easier for you to understand NASA, and hopefully it'll be beneficial. And then some closing remarks. All right. So a summary about me. Oh, before I do, this is I have to do a disclaimer. Okay. I'm talking about careers in aerospace. I am not a certified career counselor. And, the views and the opinions that I express here are mine based on years of experience, and they're not part of NASA per se. I didn't get this from a NASA book on careers in aerospace or career recruiting. It's from my own experience, and I encourage you to seek advice from a certified counselor. What I'm going to be doing here is just kind of sharing information that I know that perhaps will help you better ask questions with your career counselor or somebody that's in the field of helping you choose a career. So about me, I did not come from a well-to-do family. You see up here at the top a shotgun house. I grew up in the ghettos or the barrio of Corpus Christi, Texas, which is just south of Texas, not too far from the border of Mexico. Um, there's a picture of my grandparents. They came from Mexico, no education whatsoever. To the right, to your right is a picture of my dad and my mom. This is a picture of them when they were out picking fruit and vegetables in northern part of the United States. My dad had just gotten out of World War II. He was a Navy. He was in the Navy. Worked was on a destroyer. Handle any anti-aircraft machine gun on the destroyer. But they were trying to raise money, for to make a better life. And my dad only had a fourth grade education. He had to drop out to go to help the family make money to eat. My mom was had second grade education. She was actually an orphan for many years before she turned age 18 to get out of the orphanage. Down there at the bottom is a junkyard, which is not too far from where I grew up. And I learned to build things, going to the junkyard and finding things, to build and learn. It was cheap, but sometimes it was dangerous. I found a old toaster that had been thrown away, and I wanted to know how that toaster worked. And back then, there was not the electrical safety code that they have now, and I got shocked. I was very lucky; I didn't get electrocuted, but it was part of the learning process. Um, Growing up, we didn't have a lot of money. There's a shoe shine box. My uncle helped me build the shoe shine box, and I used to shine shoes. You can see I charged only 15 cents, but it helped me raise money to buy comic books because I love comic books. I love to read. That's a picture of me at the donut shop. My dad had a donut shop when I turned 10, and he taught me how to make donuts. There was no such thing as an allowance, so I had to work for my money. So that's a picture of me. Interesting enough, about a year after this picture was taken, my dad suffered a heart attack, and I had to run the business while he was in the hospital until he got better. Down here at the bottom is a picture of a slot car system, and I got into slot cars. And I have to say, this was my introduction to electric circuits, and because these slot cars had a 12-volt motor, and they operated by these slots right here. I hope you can see these little things that are made out of aluminum, and one of them had had the minus and the other one had a plus 12 volts on it. And you control the current by these controller devices. And so that's how you made the car go faster or slower, just by pressing this trigger on this, I call it a variable resistor, if you will. So it was a lot of fun. It was kind of expensive, but that's why I worked. And I learned a lot. I learned about making motors, about soldering, a whole bunch of things. It was just something that I enjoyed. Um, we moved to Houston because a hurricane devastated Corpus. And when we moved to Houston, I did not have an idea what I wanted to do in college. So I worked in construction. I went back to making donuts at Shipley's Donuts, and I worked at a Kmart. I wanted to make a career change, and I tried to take tests to get into Xerox as a Xerox machine technician, but I failed the test. It was made of digital electronics, and I could not understand what I didn't understand what all those equations and all those electronic symbols meant. So I tried again. I tried IBM copiers, and I studied a little bit about electricity, and I did okay in the electricity, but not too well in the mechanical part. So I failed. I tried to get into radio and TV repair as a repair technician, and I didn't like the schooling at all. The schooling was terrible. The instructor was terrible. Didn't know how to teach, and so I dropped out. Got married, and then took a break. And then finally, when it was time to want to go back to school, uh, my grades were not that fantastic in high school. I graduated lower 20% of the class. So I had to find a junior college that would accept me on a probation basis. I tried to take the SAT and didn't do well. So I went to three different junior colleges here in Houston, and one of them accepted me on probation. And within 2 years, I got my 2 year Associates of Applied Science and Electronics Technology degree. I transferred over to the University of Houston, where I got my bachelor's in electrical engineering. There's a picture of my daughter as part of the graduation. 21 years later, I went back to get my master's in systems engineering. And because my grade point average was not that fantastic at the University of Houston, I was admitted on a probation basis, and I excelled and got my master's in systems engineering. There's a picture of my daughter, 21 years later, and then my other daughter on my left hand side or your right. So how did I get to NASA? Well, for one, NASA hires a lot of engineers. 60% are usually engineers in some fashion. So I had to get my electrical engineering degree. While I was going to school, I was doing repair. I was working as a repair technician and counting calculators, and gained a lot of valuable experience about how to do repair work on electronic systems. I was under the wing of a Japanese technician from Canon in Tokyo, and he taught me a lot about troubleshooting using equipment. And as part of that, he taught me how to use chopsticks. You see a picture there of these two probes for a multimeter. And instead of using two hands, he showed me how to use chopstick method, so I could use both probes with just one hand and free up my other hand to to handle electronic circuits and probe the circuits with the meter probe. So that's how I learned how to use chopsticks by by repairing Canon calculators. I was told that I needed to do internship if I wanted to be, let's say, a good candidate for getting a full-time job when I graduated from engineering. though I have to say there were times where I didn't think I was going to graduate from engineering. It was very, I had some very difficult classes to get over with. But needless to say, I wanted to work at NASA because I got to know some friends there at NASA. But again, my grade point average was low, and so NASA did not accept me. But there was a company called Geosource that accepted me to work as an engineering technician, making what we call geofoams and hydrofoams. And geofoams are used for exploration of finding oil out in land, and hydrophones are used for exploration of finding oil under the sea. So I gained about a year and a half experience in engineering, in the engineering technician field. Uh, I managed to help design a circuit to test these devices, and also created a robotic system that was used to make the assembly line more efficient. Uh, when it was time to graduate, NASA, it turned out, had an opening because a technician, or I'm sorry, a student declined the offer to come work at NASA, so they opened it up to the street. And so I was competing with other university students in Texas for that spot. And I have to say that it wasn't so much my GPA or my grade point average that got me in, but Mr. Robert Brown, who was the chief of the crew and thermal systems here at the NASA Johnson Space Center that interviewed me, liked that I had all this experience under my belt. And he said that a lot of engineers that have worked in NASA had a lot of experience under their belt. In fact, he shared with me that the Apollo space program was one of the reasons why it was so successful was because a lot of the engineers had a lot of experience under their belts. So he said, come over to NASA for a second interview. And when they tell you to come for a second interview, it's almost, as I learned, it's almost a guarantee that you're going to get a job. So I came to NASA Johnson Space Center and interviewed in the Tracking and Communications division, and I almost didn't take the offer, but the division chief wanted me to come work at NASA, and so I accepted. And I've been with NASA now, close to 40 years. Um, so let me start switching gears and start talking a little bit more about careers. And uh, let me just first kind of preface careers at NASA with what does NASA mean? Because students and even adults use the word NASA so loose. It's like, okay, oh, that's NASA. That's NASA. NASA does that, and it they really don't stop to think what NASA is. And so I'm breaking it down here that NASA stands for National Aeronautics and Space Administration. Aeronautics. Why aeronautics? Because we do aeronautic work, atmospheric testing of airplanes, jets. Here you see the Gulpy. Gulpy was instrumental in transporting space station components to the Kennedy Space Center to launch on Space Shuttle. The T-38 right here is used for astronaut training. The WB-57 bomber is a research vehicle. It's an awesome jet craft. It goes up to 60,000 feet in the air and does research at high altitude. This is another ER-2 aircraft that does research, atmospheric research. In fact, it flies into hurricane eyes too as well. And then, we do experimental work, like, for example, the X-48B wing body, which is going to be some of the work involved with supersonic air transport. So this is aeronautics, okay? Atmospheric vehicles that operate in the atmosphere. And then there's space, which most people, students understand and know. And of course, the Apollo space program was one of the highlights of the space part of NASA. We went to the moon and landed on there 6 times. A total of 12 astronauts walked on the moon. Space shuttle, that's what I started with. Space shuttle was a very interesting vehicle. It had both the space aspect and atmospheric aspect. Of course, atmospheric was because they had to travel through the air when it launched. And then, but once it got into space, the space shuttle was an orbiting spacecraft. But coming back, it came back as a high speed jet aircraft, if you will, doing Mach 20. It was an incredible flying machine given the technology of the 1960s and early 1970s. And then, of course, space station is currently orbiting around it's been orbiting now for a little over 20 years. A lot of research in understanding how humans can live and work in space, developing technology that one day will take us to the moon and learn to live on the moon for a long period of time, and then eventually create the dress rehearsal for taking us to Mars. I work on the commercial crew program, and part of that commercial crew program is working with SpaceX, and there you see the Dragon spacecraft module getting ready to dock with the space station. And then the Orion spacecraft, which just recently flew to the moon and did a 21-day orbit, 21-day mission around the moon to check out the systems. There was nobody on board other than a mannequin, but it gathered a lot of information about the engineering of the systems. Artemis 2 is planned for launch, I think, next year. They're going to have 4 astronauts, and you probably saw news about the 4 astronauts that are going to go to the moon. They're not going to land on the moon, but they're going to the moon and circle there for a few days and check out the systems. And I'm currently working on the human lander system as part of the Artemis program. Artemis program is the program returning to the moon. It's kind of like the Apollo space program back in the 60s. Part of that, a critical component, is the human lander system that one day will land humans on the moon. As you can see, right down here are the people, and this is just a picture representation, but you can see how big this human lander is compared to the people. It's a massive ship, and of course, Elon Musk from SpaceX wants to use this spaceship to eventually populate the solar system. So there's a lot of work going on. Of course, SpaceX tried to do a launch of the Starship earlier last week, and it exploded, unfortunately. But it was a good learning experience about why it happened, and SpaceX is very good about taking a setback. I don't want to say a failure. A failure is only happens when you stop trying. But it was a setback, and from that they're going to learn what went wrong and build on that and make it better. So here is NASA, as people call it. As you can see, it's not just one center. It's a bunch of centers, okay? I'm located here, Johnson Space Center. But we have Kennedy Space Center, where we launch, Stennis, where we do rocket development, Marshall Space Flight Center, that's currently responsible for the human lander system, Langley Research does aeronautics, NASA headquarters. This is all where the where the big wigs are from NASA. Wallops, they do suborbital flight testing. Goddard does a lot of power and propulsion. And then they do studies there at Goddard. We got a software independent verification validation facility. We got Glenn Research Center that does also research in various satellites. Ames Research that does human research. as well as unmanned research, unmanned vehicles research, Jet Propulsion Laboratory that does robotic missions, Armstrong Flight Research Center that does atmospheric research with jet aircrafts. White Sands Test Facility does quite a bit of testing, like, for example, testing of materials for flammability and off-gassing. So, and then the Johnson Space Center, we're basically the center for human spaceflight. Um, so let's get into engineering, and this is just uh, some of the areas. Okay, obviously electronics engineering is a biggie. That's what I got my start in, uh, and thermal systems, like for example, thermal insulation on a spacecraft. Like for example, what you're seeing right here is the thermal insulators on the Orion spacecraft when it returns to Earth. Propulsion, a lot of aeronautical engineers and mechanical engineers get into power and propulsion, and that's a biggie. And of course, some of the skills that they develop is computational fluid dynamics and modeling of high-powered propulsion systems, guidance, navigation, and control. Basically, this is the algorithms to acquire sensor data like star trackers and inertial measurement units, and take that data and try to figure out where the satellite is in space and control the satellite in space. Structurals, usually they're mechanical engineers, aerospace engineers as well, and they develop structures for, like, for example, this is the Orion spacecraft structure. Robotics is a big area. That's here at the Johnson Space Center, as well as Ames Research Center, and we're developing robotic applications that can help astronauts in future space missions. Um, and then there's specialized fields of engineering. It's not like you're going to get a degree in it, but there's some engineers that become fabrication engineers. In other words, their whole expertise and development is in how to fabricate systems, especially complex systems, um, dealing with materials that are very fragile, that can crack. How are you going to manufacture that? And so they develop techniques of fabrication. Um, Materials, okay, materials. That's also a biggie. We have to be careful about what kind of materials go into space. We don't want it to create a fire, or if it starts to smoke or from a fire, the that the material doesn't have toxic properties that big thing. Test engineers learn how to develop test equipment for testing unique systems, like for example the Hubble Space Telescope. The testing equipment for that, you can't go to a Walmart and buy that equipment. It was specially customized equipment that had to be designed for testing the Hubble Space Telescope, and most recently the James Webb Telescope. Extra vehicle activity suits, the extra vehicle spacesuits are basically, if you think about it, it's a one-person spacecraft. This thing is basically a life support system for one astronaut. There's communications, there's life support, and there's even a little bit of drinking water and eating inside there. That it takes a little bit of design to design that into the helmet so they can eat and drink water while they're working in outside the spaceship. And of course, the material involved with building these spacesuits, it's quite challenging. And so there's people that dedicate their lives to doing what I would call spacesuit engineering. And then there's the electrical electronic parts. Okay, these are engineers that get to know the limitations and capabilities of electronic components and whether these components are suitable for the space environment. One of our biggest challenges for deep space is the radiation environment. And so these electrical and electronic parts engineers help identify which parts are going to be useful or going to be suitable for the deep space environment. And they help create special tests called radiation testing, um, to help understand how these components are going to behave in a radiation environment. We got radiation test facilities here in the United States, and I know there's some in Europe that'll test using high energy protons and heavy ions to see how these components behave in that kind of environment. And then we got systems engineers, systems engineering. So this one, that's a kind of like what I am, is basically engineers that develop the skills, very much general type skills for leading a project in the design, development, tests, and deployment of those components. And so these systems engineers not only know their area very well, let's say electronics, but they also know generally about other areas too: mechanical, propulsion, materials, and of course there's safety engineering as well. And so these systems engineers are basically call them I guess I call them the orchestra maestro, if you will. They basically lead a team of engineers in developing complex systems. All right. So I'm going to also share with you, this is not necessarily engineering per se, but this is more in the scientific area. And I know, sometimes people will say an engineer is a scientist, and not necessarily. Um, Scientists kind of seek to understand how nature works, and engineers basically take their knowledge and applied engineering to develop systems that are used by people. So in the scientific world, we have human systems integration, understanding how humans behave, operating systems. We've got hypervelocity people, physics, a lot of physics. When you talk about hypervelocity, you're talking about kinetic energy, right? A piece of mass with a certain velocity puts out a certain kinetic energy. And, at very high speeds, even a very tiny, small half a gram object can make a big damage to a piece of metal. We have a food lab. We got food engineers that basically dedicate their lives for developing better food that'll last long periods of time, and that's going to be important, especially when we go deep into space. You don't want food to go bad after a couple of years. Geology, we got people here at the Johnson Space Center that know about rocks, they know about sand and all that, and they're studying that to see how we can use, let's say, for example, the soil of Moon and Mars for keeping humans alive on another planet. And then there's astrophysics. Astrophysics is basically the study of planetary systems and to some extent biological systems on another planet. And so you got all these different kinds of spaceships or rather satellites that are acquiring data that astrophysicists use for gathering data about exoplanets or other planets. And here you see the Hubble Space Telescope, and of course the James Webb Telescope is now seeing even further than the Hubble Space Telescope. And then there's other careers. I'm just going to say these in passing. You know, and these people, NASA, the people that work at NASA work in these areas: budgets, contracts, administrative. These are people that are basically help NASA accomplish its missions. We got medical and clinical. We have a clinic here that not only help basically provides free service to a lot of our employees in terms of health checks, but they also have flight surgeons or doctors that work with astronauts, to see the mental and physical health of them. But we also have attorneys, lawyers for contracts, working with other countries, working with other commercial companies as well. Maintenance, maintaining the facilities at the different NASA centers, and of course, transporting critical hardware. Transportation gets involved with some major transportation of of large spacecrafts, like for example the Orion spacecraft or the shuttle back in the shuttle days, the boosters. So it's a lot of people involved with this. Duties of an engineer, they have to be involved with design, manufacturing, and test of products from prototype to the actual product. Early on, they do prototype testing to see what worked, what doesn't, and then eventually they develop the final product. Design encompasses many things: part selection, modeling, development. It's a major undertaking. Assess the feasibility of the design. Engineers have to assess: is this system going to work or not? Ability of a design, especially like in human spaceflight, is not just that the hardware and software design, but it's the hardware and the software operating in the environment to accomplish the mission in a certain environment and time frame. And of course, you got the human involved. The human, if it doesn't, he or she doesn't understand how the system operates, the system could fail. Evaluate the design for meeting requirements. This is something that's real big in systems engineering, is requirements writing. Develop acceptance criteria for a product. What are we gonna, what can we test, and how are we going to test to tell us this system is the right system that we wanted? Support other engineering product development. Things like, for example, hazard analysis. What are the hazards associated with the system to occur? And of course, you got to write weekly reports. I didn't think I was ever going to have to write stuff, but I did. A lot of report writing. Technical papers related to your work, and this is where you start developing your skills of becoming a better technical writer, and also becoming noted in your field of expertise. Meetings, unfortunately, you're going to attend a lot of meetings, and it can be a few too many. I never thought I was going to attend so many meetings in my life, but it's just part of the duties of being an engineer. Soft skills. There's a whole bunch of soft skills here. Teamwork obviously is important. Being a good listener, negotiating. How are you going to negotiate requirements? How are you going to negotiate which is the better design? Communications, both oral and written. Motivating people. If you're a project leader, how are you going to motivate your people, especially when they're working long hours to meet a schedule? Conflict resolution. Sometimes you're going to have conflicts among employees, and so how are you going to resolve those conflicts? Additional skills, I have to say, you have time management is obviously critical. You got to be a good observer. You got to see, okay, this does not seem right. Okay, you look at the data, and you determine that there's something wrong with the data. It's not what it should be. Analytical actually goes with observant. You have to be very analytical in figuring out how to approach a problem. And I tell students that real world problems and book problems are not the same. Book problems have an answer at the back of the book. Real world problems do not. You got to figure it out yourself, and that's why you got to be analytical. Adaptive, things are going to be changing, and you got to change along with them. Sometimes you think your design is perfect and everything, but it turns out that something else in the design of the system made your design not the right solution. And so you got to change your design. Some engineers hate that, but that's the name of the game. Diligence, you want to make sure that you're a hard worker, obviously, especially if you're having schedules to meet. You want to be a very curious person. I think most engineers, scientists are. but it's just an additional skill that helps you, I think, develop as or engineer or scientist. And then some final remarks. Is a career in aerospace can be very rewarding. I certainly enjoyed my years working here at the NASA Johnson Space Center. Not all skills to be a successful engineer taught in school, like soft skills. They are not taught in school, or additional skills that you learn on the job. And then grades don't make the person or career. Based that on my experience, it's more of determination and hard work. And I mentioned this earlier, you only fail when you stop trying. Otherwise, it's a setback. So never, whenever you suffered a setback, don't think that's a failure. It's just one way of not doing it. Like the Thomas Edison, it took him something like 10,000 tries before he finally invented the light bulb. And reporter told him, "Sir, you failed 10,000 times before you discovered the light bulb." And Edison told him, "No, I did not fail 10,000 times. I just found 10,000 different ways of how not to design a light bulb." So each trial, he learned something new. And the only challenges you face are the ones you put on yourself. And I found that to be true, especially when I was going to school. So that basically concludes my presentation. And I am going to stop sharing and start seeing if I can answer questions here. Um, all right, so I see some already here. How to join NASA, being a BT Tech aerospace student. So NASA only hires U.S. citizens, and a lot of the contractors do, just simply because sometimes some of the work is very uh, uh, confidential, secret, and so you have to be a U.S. citizen. Not to say that you come from India and you cannot come work for NASA. I know a student right now um, that I met her 5 years ago, 6 years ago. She was a high school student, and she wanted to come work at NASA. And I said, okay, well, it's going to be hard. You're not a U.S. citizen. So she said, well, I don't care. Tell me what I need to do. And I just looked around and I said, well, one thing, you got to come here to the United States and get a degree from a United States college, master's degree, and then maybe one day get a PhD degree and start accumulating time here in the United States, where you can get a visa. Well, long story short, I got a note from her last month saying that she's been offered a job at Jet Propulsion Laboratory, working in AI for robotics. So it's been a long road for Vasuda, but it's not easy. All right. How propellant alternatives are important for future space missions to other planets? Well, that's a good question because the faster we get to another planet, the less exposure a astronaut will experience in terms of radiation. So the faster we can get to other planets, the better it is for the astronauts. So propellant alternatives are important. I mean, there's different areas going on right now. Nuclear power propulsion. There's a former astronaut, Dr. Franklin Chang Diaz, that's developing a plasma rocket that'll take us to Mars in 30 days rather than 9 months. So we're looking at different ways, but it's a challenge. It's a challenge in terms of pros and cons. For everything that you think is going to work, you got to look at why it's not going to work, and sometimes the cons are a lot more than the pros. So you have to figure how to get around those. Um, let's see. Here's another question: how a rocket scientist students become an astronaut, and how do they prepare themselves to become an astronaut? Well, I mean, it's not necessarily just being a rocket science student to become an astronaut. We've had astronauts that are biology majors that have a PhD in biology. We have an astronaut that is a medical doctor. Um, we had one engineer, I'm sorry, one astronaut uh, that got a PhD in electrical engineering, got a medical degree, and he also became a certified machine welder and also a certified machinist. It's those things like that that separate you from other um, applicants to become an astronaut. You know, a lot of astronaut applicants are 4.0s. I mean, they're, one person says, well, I'm a 4.0, that'll get me an astronaut. No, no. There's a lot of 4.0s out there. So what you have to do is separate yourself from the crowd by doing additional things, flying an airplane, being a scuba diver, being a certified machinist, things that you wouldn't think would be applicable. There's one engineer that she was a theatrical performer as well. And so, there's some things that you don't think about. So you have to separate yourself from others. And of course, to become an astronaut, at least in the United States, you got to be a U.S. citizen. So that's your first hurdle. But now with India having a space program, human spaceflight program, and of course European Space Agency, there's other opportunities, not just here in the United States. And of course, one day commercial companies are going to ask for commercial astronauts, and so you try to do everything you can now to prepare yourself. Um, is there any scope of Indians working with NASA for aviation related projects or jobs? Um, yeah, I mean, I think there are some Indians, and I have some friends of mine that are formerly from India, but they became U.S. citizens. And worked for NASA. Um, in fact, there's one gentleman, Dr. Kumar Christian, that recently retired from NASA, and he was from India, and but he did a lot of good work during the Apollo space program. Um, and then, of course, we work with India and some of these unmanned space flights. I think there was one that went to Mars that I think NASA worked with. So NASA does work with India in some fashion in projects. If you're a non-traditional age student, do you think it's hard to get your foot in the door? Uh, I, I I was a non-traditional, somewhat of a non-traditional age student. I was a lot older than a lot of the students or people that came to work for NASA, and sometimes that was actually to my benefit. I feel that because I was older, I was more mature, and so that helps in applying for a job because they see that you're more mature than, let's say, a 21-year-old out of college. It's just a matter of trying to find, get your foot in the door. I know they hired a contractor, and I think that person was in his early 40s. So, there's, you just got to try. You just got to keep trying. Does the college from which you graduated or grades matter much to get into the space industry? It does to some extent, but again, I was not a student. Um, I graduated with a 2.72 average, but I had experience under my belt, and the whole thing about grade point average is kind of hard sometimes to say, well, 2.7 from this college is equal to 2.7 from that college because sometimes it's the professors. Okay, I had some good professors, I had some bad professors, um, and some professors were from industry and they taught me practical stuff. There were some professors that were all theoretical, and I really didn't learn anything. Like one professor I had, he actually taught let's see, what was it? The calculus two, integral calculus. Uh, but he taught practical integral calculus because he worked as a researcher at John Hopkins applied physics labs. And he also worked as a researcher at Massachusetts Institute of Technology. And so the way he taught the class was what he called practical integral calculus. And he did, he would say, I am not going to give you mind exercise or test questions. And he never did. They were all practical. So I really learned a lot from him in my graduate studies. All of my professors, except for one, were seasoned systems engineers. They had actually worked as systems engineers, and they shared with me what worked and what didn't. Sometimes what's in the book is not the way it happens in the real world, and I was very thankful for that. And that's a big lesson that I took away, is to choose professors that actually work in the field rather than theoretical. If you want to be a theoretical person, fine, but if not, I am not a theoretical person. I'm a practical person. I want to build things. Um, let's see, what's the best way to get noticed by hiring managers? I have to say that it's not just, to some extent your grades, but how you present yourself, and that's where your soft skills come into play. Your how you, your communication skills, how well you communicate, how well are you listening, are you watching, are you, eye contact, how you handshake. There's things that you develop in terms of the person that that you can stand out. I know that when I was applying for this job, there was a couple of 4.0s in electrical engineering, but they were both very much introverts and didn't speak. I have to say, didn't speak very well. And I have to say, I practiced a lot speaking, interviewing, and maybe that helped. But you just have to do everything that you can to to be a good candidate. There's a high school student uh, says space institutions working on space plane concept nowadays. Let's see, sir, I'm a high school student. Are space institutions working on space? There are some. I think there are a lot of institutions working in space plane concepts. I know here in the United States we have a couple, but I'm not sure about other. Use the power of internet to search. I'm sometimes surprised that students that grew up with internet. I did not grow up with internet. I used to go to the library and check out books. Uh, use the power of internet to search, to ask, ask the questions to Google and get answers. There's a lot of good information out there. So don't wait. Don't wait to be. They call it spoon fed. You go out there and search. Does NASA have summer jobs for college students? Yes, they do. There's something called the internship program, and you can get not only summer jobs, but sometimes during the year to get the internship experience. There's no guarantee that you'll get hired uh, working those internships, but at least you're getting experience. Now, there is a pathway internship program at NASA where after doing 3 internships, you are eligible to be hired if you put out good work. Let's see, being an aerospace student, how should our approach toward our college subjects? The thing is, you're going to have to take those college subjects and you're going to have to deal with professors, different kinds of professors. I encourage you, sometimes, some of the theoretical stuff, the equations and all that, is to ask a lot of good questions. Okay, how does this apply in the practical world? How does, how would I use this, to develop a space plane? Start asking questions and find out, if the professor can share it with you, something related to that subject and how it's practical in the real world. I took a lot of thermodynamics, and the equations were just horrible. And then when I came to work at NASA, I learned that a lot of the thermal stuff that I needed to learn for electronic heat transfer were simplistic. It was just amazing. It was just amazing. Let's see. I am running out of time here, so let's see. Let's see. If there are two people with a similar profile applying for a job at NASA, but one has a master's in aerospace and the other has uh, the same in mechanical engineering, is there a preference? Not really. It depends on what the job entails. If they're applying for the same job, and let's say the mechanical engineering student has taken classes in systems engineering, And this job requires systems engineering background. That mechanical engineering is going to have the edge over the aerospace engineer. So a lot of it depends on what the job application is, and that's why you got to prepare yourself as much as you can, and then learn the ropes about developing good resumes. And sometimes you cater your resume to the job that you're applying, and each resume can be different based on the job that you're applying for. And that's all the time I have. It's 8 o'clock. Sorry about that, but I got to get ready for some other stuff. I hope this was beneficial to you guys. Um, and I wish you all the best of luck. I know there's some folks online that I'm familiar with their names, and so I'm sure I'm going to get more questions later. But for the time being, that's all I have the time for. Thanks. All right. Well, thank you for having me, and I wish you all a good rest of the day or rest of the evening, and I wish you all the best. So you all take care.
Uh, Hello. So now, before concluding the session, I would request everyone to turn on their camera once to take a picture. So before ending the session, I want to thank Sir for giving his valuable time and enriching us with your knowledge on this topic and helping all our participants with the topic. Secondly, I want to thank all our participants for joining the session with us and helping us organize this session successfully. We have also many more interesting sessions like that in our YouTube channel, so you can check it out. And there are also two live masterclasses are ongoing on computational fluid dynamics and rocketry. You can also register there if you want to. And with this, I think we can end our session here. Thank you everyone for joining. Goodbye. And if you can, and if you can also join our community where the space enthusiast people are there on, and the link is in the chat. You can join from there.